Okay, so last day we looked at relations, and now we take a look at how to graph these relations in the beginning of a two-part series. Today's part one. Let's remember what a relation is. A relation is some connection between an input and an output. And from the little cartoon that you saw in the last video, you saw that there was the input, which in that case, in the example, was a chicken, and the output were a certain number of nuggets. So the input machine did some stuff to the chickens and turned them into nuggets. So you can think of a relation as being some kind of machine that takes an input, in this case the chickens, and turns them out to be something else, nuggets. Now, how would you be able to graph that? Well, to graph a relation like this, we need to know how to translate the input and the output so it can be graphed. Now, a little refresher on what graphs I'm talking about. This is the same kind of graph that you did with that graph a mole activity at the start of this unit. It's not just the kind of graph where you have positive numbers. There's also regions of the graph where you have negative numbers as well. And there's two axes or lines on the graph, main lines. You have the x-axis and the y-axis. To refresh your memory on what a graph looks like, let's take a look at a graph here that I have, and I may have given this to you to work on. Don't know if I did or not. So here's a typical full graph. It's called a Cartesian grid or Cartesian graph, because it's not just this section here, which you're used to dealing with in science and socials and whatever, just positive numbers. It's also got negative numbers. There's 4 parts to it in total. Again, this is the part that we normally, when you deal with bar graphs and stuff like that in science, we normally only look at this section, but there are actually 4 full sections to the Cartesian graph. They call this quadrant 1. They usually use it Roman numeral 1, quadrant 2, quadrant 3, and quadrant 4. I don't know why I'm saying that. That's just one of the little useless things that sometimes that people ask you. So, as you can see, what is the graph? It's just a number line, an x-axis number line, negative 10, negative 9, 0 right in the middle, all the way up to positive 10, intersect another number line going vertically. The horizontal going straight across is the x-axis, and the up-down is the y-axis. So all they are just number lines, and they're grids linked together. You remember doing this, you did the graph-a-mole thing, and you were able to know that, for example, if I said 3, negative 2, the first number is always the x, the second number is the y, so 3, negative 2. So 3 on the x, and negative 2 on the y. Where those 2 points would meet, that would be the point there. Okay, so that's just a real quick little refresher from that graph-a-mole thing that you did last day. Okay, so let's get back to the business of this topic. We'll come back to the graph in a second. So translating graphing language to relation language, the graph has an x-axis, and that is for the input values. That's what you're putting in. You put an x value into the relation machine, and you get out, the output is a y-axis or a y value. So the y-axis is for the outputs. Okay, let's take a look at an example here. Looking at here, Sam's age is Bob's age plus 2. Now, what would the relation be? How could we translate that into an equation? Sam's age. We don't know what Sam's age is, so let's just call it S. And Bob's age, we don't know, so just call it B. So Sam's age can be S, and Bob's age can be B. The input here and the output. What is the output what is the input. To figure out Sam's age, we need to put in Bob's age. So Bob's age is the input. So we'll put B for input, and what you get out is Sam's age. Sam's age is the output. Like it says here, Sam's age is the output, and Bob's age, B, is the input. So this was the equation that you'd come up with based on that, translating that sentence into an equation. Sam's age is Bob's age plus 2. Remember, the is means equals. Okay, to graph this, we need to remember that input values go on the x-axis and output values go on the y-axis. So we can use y, instead of using S and B, S for Sam's age, B for Bob's age, we can instead substitute the input, which is Sam's age, the output, which is Sam's age, for the letter Y, and X is the input. So we can basically take this and get it ready for a graph by using X's and Y's. The output, Sam's age, becomes Y, and the input, Bob's age, is X. It's always that way. So now we've taken this word equation and we've got it ready in terms of X's and Y's to do a graph. Okay, so now we can graph it, but how? Here are 4 steps to always know how to graph any relation. There's a relation there, that's the relation there. How do we graph this relation or equation? First step is you need to rearrange the equation so that the output value, which is the y, is by itself. Now you have y equals x plus 2. Is the y by itself on one side of the equal sign? Yes, it already is. So step 1, we don't have to do any work. It was already done for us. Y was already by itself on the equal sign. Y equals x plus 2. Now the rest is stuff that you did before. I don't know what happened here with all the spacing. Okay. So next what you do is you make a table of values and pick any 5 numbers for x. So make a table of values like this. You can do it sideways to save paper. Last day we did it going up and down. And for x, you can pick any 5 numbers you want. Any 5. Look, the freedom is going to be dizzying for you that you can have that many, that much freedom to pick any numbers that you like. Here's what I suggest you do. You pick, your 5 numbers that you pick should be equal amounts of positive and negative numbers. So don't just pick all positives. You want to pick some negatives just so we can see the entire graph, what it looks like. Remember, because our graph, it's all zoomed in here, but the graph has negative and positive values. We don't want to just see what the graph looks like on one positive quadrant up here. We want to see how it looks like all over the graph with the negative as well. Okay, so the numbers that I suggest that you pick are these 5, and that's what I call these my favorite 5, or fave 5. -2, -1, 0, 1, 2. Now I know I just told you to pick any 5, but I strongly suggest that you pick these 5 because 2 reasons. There are equal amounts of negatives, 2 of them, and positives, 2 of them, because 0 is not negative or positive. And they're the smallest numbers you can get. And we're all lazy. We don't want to have to do math calculations with crazy numbers and stuff. So you want the smallest numbers possible, and you want them to be equal amounts of positive and negative. Well, these are the 5 that are going to work the best. Next, this should be step 3. Treat the relation, which was this thing here, the y equals x plus 2. Treat that as an input-output machine and sub in each of the 5 x inputs to find the y outputs and fill in the whole table. So this we did before. What you're going to do is you're going to sub in -2 into this equation, figure out what you get, just like the chicken going into the machine and seeing what output we get for a y, and we fill in the table, just like we did last class. So For this you might need some room. That's also another reason why I picked these 5 numbers in order. I didn't just pick like random numbers. If you do it in order, then you can do that pattern thing I showed you last time, where you can see a pattern and you can fill in the rest of the table without having to calculate everything. So what we're going to do is we're going to take this equation, y equals x plus 2, and we're going to sub in each x value into this equation. So for negative 2, when we sub negative 2 in for x, y equals, remember, whatever we sub in goes in brackets, plus 2. Negative 2 plus 2, you're down 2, you're up 2, it's 0. Y equals 0. So at negative 2, y equals 0. We put negative 2 in the machine, we get out 0. Okay, let's do the same thing for negative 1. So for x equals negative 1, we go y equals x plus 2. We sub in a negative 1 in for x. Y equals negative 1 plus 2. You're down 1, you're up 2. Y equals positive 1. So positive 1 goes there. Let's just do a third one just to be sure. So for 0, y equals x plus 2. We sub in a 0 in for x. Y equals 0 plus 2. And 0 plus 2 is 2. So when x is 0, y is 2. Now, do you see a pattern? Yes, you do. You see that the y's are going up by 1s. So this one must be a 3, and that one must be a 4. So there we have our table filled in. Nothing new. The next part is to make the graph. Well, how are you going to do that? How are we going to graph this? Remember, these are x values. These are y values. So the next step, which is, we just filled in the whole table. Next what we need to do is realize that this table is actually 5 points on a graph. Here's an x value, there's its y value. Remember from the graphomole thing that this point is going to be called negative 2, comma 0. Negative 2 on the x, 0 on the y. That's one point we're going to plot. The next point is going to be this. Negative 1, comma 1. Negative 1 on the x, positive 1 on the y. X always goes first. And then the other point we're going to have is this here, 0, comma 2. 0, comma 2. And then 1, comma 3. 1, comma 3. And then 2, comma 4. So those are our 5 points that we're going to put on the graph. I'm kind of going all over the page here with the notes. So we did step 3. We filled in the table. And then step 4, is that we're going to realize we just made 5 ordered pairs that we'll use as coordinates on our graph. And then we'll graph the coordinates on the graph paper. So these coordinates right here, 1, 2, 3, 4, 5, we're going to put on our graph. Okay, so let's put this on the graph. Negative 2, comma 0. On our graph paper, we're going to plot negative 2, comma 0. That's the first point. So we're at negative 2 on the x-axis goes first. Negative 2, comma 0. 0 on the y. Well, negative 2 is here. 0 is that right there. So our first point is going to be right there. Put a dot right there on the line. What was the next point we had to graph? Negative 2, comma 0 is done. Now it's negative 1, comma 1. Negative 1, comma 1. Negative 1 here. So again, negative 1, comma 1. Negative 1 on the x, 1 on the y. Negative 1 on the x, 1 on the y. So these two would meet right there. That's our second point. That one's done. Now 0, comma 2. 0 on the x, 2 on the y. 0 on the x, 2 on the y. 0, 2. And just like we did before, you can almost see a pattern here. You see that we're going to have a nice straight line. Just to make sure, let's just go through them. 1, 3, and 2, 4. So 1, comma 3, 2, comma 4. 1, 3 goes right there, and 2 and the 4, they meet right there. So there is 5 dots. Now we connect them. Do not do a cheap stubby line. This line goes on forever. I mean, it's not just as long as this. We just happen to pick those 5 random numbers. This line actually goes on forever. So you should draw a line that goes on forever. So start drawing. It's going to take a long time to draw forever, isn't it? Well, you don't have to actually draw forever. You draw a line, and it should have arrows on either end of it showing on forever. Now I know I didn't go completely through the dots there. That's because I was using the computer's thing. But you should use a ruler and a pencil. Other than graphing, you should always use a pencil, and you line up the dots. That is the graph of our equation, which we should also label on the graph as well. Remember what was the relation here? It was y equals x plus 2. We should label this line y equals x plus 2. That's what it looks like. It looks like this. And with that graph, we can then predict a connection. Well, I wonder if x was negative 6. If x was negative 6, y is going to be negative 3. Oh, what if y was 5? Well, if y is 5, x is going to be 4. So having a graph allows you to make predictions of what all the other values are for it, forever, for infinity. Okay, so that's how you graph. I know the first time you saw it, you're probably thinking, oh my god, that looks really hard. You know what? It's the first example only. It's no big deal. Here comes the next example. And as long as we follow our 4 steps, this should be not a problem at all. Okay, now I'm going to not worry about the whole word problem thing. Let's just jump right to the relation y equals x plus 4. Remember our 4 steps. First, rearrange the equation so that y is by itself. It already is. Y is already by itself. Make a table of values and pick your any 5 values of x. Again, sorry for taunting you and giving you that illusion that you have the freedom to pick any 5 numbers, but really we should pick these 5, our favorite 5. Negative 2, negative 1, 0, 1, 2. You should pick those 5. Again, you don't have to, but trust me, I know best. These will work the best on your graph. Okay, and you sub each of these x values into the equation and spit out a y. So for x equals negative 2, we use our new relation now, y equals x plus 4. We sub in a negative 2 in for x, so y equals negative 2 in brackets plus 4. Negative 2 plus 4 is 2. So when it's negative 2, the y is positive 2. Okay, let's do it for negative 1. So for negative 1, y equals x plus 4. Let's sub a negative 1 into the equation. Y equals negative 1 plus 4. You're down 1. You're up 4. You're at 3. Now, do you have to do all this work for each one? No. I'd like to see it at least for 2 of them. There's a few other ways. You could use common sense. If we plug 0 into here, 0 into this, if that becomes 0, then what does y become? Well, the x goes away. You're left with y equals 4. So this one's obviously going to be 4. And then you can see a pattern. 2, 3, 4, 5, 6. There's your pattern. So those are also our points that we can plot on a graph. Negative 2, 2, negative 1, 3, 0, 4, 1, 5, 2, 6. Now if you want, you can rewrite them as the little bracket thing, where this becomes negative 2, comma 2, that becomes negative 1 comma 3. If you like it in this form, then maybe make that extra step and do that. But if you can go right from this grid, or this, sorry, go from this table of values and go right to your graph, good for you as well. Okay, so I'm going to use the same graph paper, and too, because graph paper doesn't grow on trees. Yeah, I know it does, but just go with it, okay? And let me just clear this up a little bit. Come on, react a little faster here. And let's just jump right from the table. And plot these points. -2, +2. So that'll be -2, +2, first point. Let's do it in different colors so it stands out. Oh, I said different color, not the same color. Let's go blue dots. What was the next point that we had? -2, +2. The next point was -1, +3. -1, +3. Can you guess what the next point probably was? Do you think it was 0, +4? It is. 0, +4. 0, +4. And then the next point, trust me, was 2, 5, 2, 5, 3, 6. No, it wasn't, was it? It was, sorry, 1, 5, 2, 6. Let me just double check to make sure that was the case. 1, 5, 2, 6. See, when you see a pattern developing, you don't have to do all the work. You can just skip a few steps. And our dots, we can line them up using our forever line. The forever line has arrows at either end of it, and it's not stubby. It goes on forever. So again, I suggest you use pencil, paper, and a ruler, because it's actually going to be better than what I'm doing here. Mine doesn't even completely go through the dots, but if I put more care into it, I could have. That's what, slow down, that's what y equals x plus 4 looks like right there. That line right there. So let's label it. Y equals x plus 4 is like that. Okay. Again, it should be, it's not perfect, but yeah, you get the idea. Your graph probably looks better than mine, and it should look better than mine. I expect it when you show me the notes that it looks better than this. With a ruler, with pencil, preferably. There you go. That's what that graph looks like. A little bit different than this one. Y equals x plus 2, y equals x plus 4. Yeah. Okay, so let's take a look at the next one. Graph this, y equals 3 minus x. So you pick your favorite 5, -2, -1, 0, 1, 2. You do the same thing. You sub in each number, -2 into here. Now here's why it's important to put brackets around what you're subbing in. Y equals 3 minus x is our new equation. We're going to sub in -2 into here. Y equals 3, whoops. Y equals 3 minus -2. Those of you who get sloppy with negative signs, why it's important to have that. You have a double negative, that's going to become a positive. 3 plus 2 is 5, y equals 5. Do the same thing for y equals 3 minus x for -1. We're going to sub a -1 in for x. Y equals 3 minus -1. Double signs, it's positive, y equals 4. 0. 0, if you put a 0 here, you get 3 minus 0, which is 3. See the pattern? We're going down by 1. 5, 4, 3, 2, 1. Plot those points. You do that yourself. I think you know how to do that. Okay. This one here. Y equals 2x plus 1. y equals 2x plus 1. Same thing, pick your favorite 5 numbers, and you sub in each of these x values into here. Now, this is again why we put brackets around it. 2 times x plus 1, so y equals 2x plus 1. We put negative 2 in for x. It looks like this. Y equals 2 times negative 2. That's what we're subbing in. Whatever you sub in, put in brackets. Whatever you sub in, put in brackets. Listen to me. Listen to me. Do it my way. Now, when you have this, please bedmass. Multiplying. You do this first. 2 times negative 2 is negative 4 plus 1. Negative 4 plus 1 is negative 3. So that is negative 3. Let's do negative 1. So again, write our equation out. Y equals 2x plus 1. Sub negative 1 into there. 2 times negative 1 plus 1. Multiplying first. 2 times negative 1. It's multiplying, right? Is negative 2 plus 1. Negative 2 plus 1 is negative 1. So when x is negative 1, y becomes negative 1. Isn't that weird? Alright, now the 0. Let's just see if you can do this in your head. If we put a 0 in for here, 0 times 2 is 0, plus 1 is 1. Now, if you can't do it in your head, by all means, it doesn't hurt to do all the work, and if that's what you're more comfortable with. Okay, now it's usually pattern time. What's the pattern as we go from here to there? We're going down by 2. Sorry, we're going up by 2. We have negative 3. Jump 2 to negative 1. Jump 2 to 1. Jump 2 more to 3. And then jump 2 more to 5. Again, if you're a little uncomfortable with the pattern, you can't figure it out, well then do another one, work it out. I don't care how you do it, as long as you fill in the table and you graph it. Now for the graphing this, I think you know how to do it. I don't need to show it to you again. I'm getting in the habit of making these long videos. I gotta change my ways. Anyway, so you graph that and it looks nice on the graph. Okay, so here's your skill testing questions. Right here, these 3. So graph this, graph that, graph that. Remember the 4 steps? The 4 steps, which are right here. We haven't had to do this at all yet. Rearrange the equation to make it where y is by itself, because all of them have y by themselves. You'll have to do this, you'll have to do that, you'll have to do that. And it's not easy. It's not hard to do once you get in the groove of things. When you show this to me, make sure that the tables are filled in. You've got some work, at least 2 steps, and that the line is properly graphed with the arrows on either end and it being labeled on the graph. Do it on the same graph if you want, as the graph paper you're given, or on the back, however you want to do it. Don't waste graph paper. Okay, and this one you have to translate into an equation. Talk to you later. Bye-bye.